Good day, everyone. My name is Elami Abraham, a trainee level undergraduate of the University of Lagos. Today, I and my team members will be discussing on the topic database and data warehouses. Our table of content consists of information resources, database, relational database, data warehouse, distributed database, and lastly, information management. Information, which is a processed data, is classified under 4 categories. We have structured information, semi-structured information, unstructured information, as well as the last category, which is metadata. Structured information are well-organized information that can be queried as well as recovered. They have an inherent structure that makes them very unique. An example of a structured information is the data of a student on the University of Lagos, consisting of the matriculation number, level, course, as well as faculty. Unstructured information, on the other hand, are information that are not organized. They are without inherent structure and are very difficult to query or extract meaningful information from or meaningful data from. Semi-structured information, which is the third one, is a thin line between structured information as well as unstructured information. The semi-structured information is in between. It is not fully structured and is partly unstructured. Metadata, which is the last category, is a data that describes the nature of information. It is what we call data about data. It describes the characteristics of the data or information, describes the type of data, as well as every other characteristics. Next, we move to the quality of information. As you can see on your screen, the quality of information includes accuracy, precision. Information must be precise. Completeness. Information must be complete in order to ensure that our decision makers are making conclusions based on all known information. The method of preparing data or information must be consistent in order to ensure that decisions are made accordingly. Information must be provided in a timely manner so that decision makers will be able to make decisions on time and avoid losses. Information must also be free from bias and must be objective. That is, it must be free from any bias, must be objective in order to achieve our goal of good decision making. Lastly, duplication of information. Information that have duplicates are usually very redundant. They are usually made redundant, and they don't form part of. They don't allow information to be well processed and of good quality. Next, we have managing information. We have 3 categories under this side. We have the record, field, as well as table. As you can see on your screen, a record is a role on a table that describes an entity. Our entity in this situation is domestic animals. As you can see, we have dog and cat. Now, the first record here is for 20147 dog. The name is Champion. Gender is male, the breed is mixed, as well as the birth date. While the field is a column, that is usually prepared using a specific type of data. The pet ID here is a column which describes a field. It's a field that describes a field. It is a field on the table that describes information. It is usually prepared using the same unique type of data. As you can see, the pet ID, the description uses text, pet ID uses numbers, name uses text, gender uses text, breed as well text, while the birth uses date as the type of data. All these put together are what we call a table. The file processing system was initially adopted by companies to process their information and data for the organization. It is usually structured in a way that each department in an organization has its own processing system. The HR has its own processing system. the finance department has its own policy system, manufacturing department, operations, and the likes. But there are several problems that arise from using this particular type of operating system. The first is the redundancy of and inconsistency of information. So many information are usually gathered by each department for their own use, which might not be useful, which might not be entirely useful or relevant. So that makes them redundant. It is usually, second, it's usually very difficult to integrate all information from different departments into one single unit because of the way of processing this data, since each of the departments maintain different processing system. There are usually inconsistent definitions for data using file processing system, as well as the high dependence on the program used by the organization, which makes it difficult for maintenance operations. Next that will be on our agenda is database, which will be discussed by my colleague here, Omolekan Bolan. Over to you, Bolan.
Basically, speaking of student of actuarial science, University of Lagos. First off, data actually. When most hear the word database, they think it's all about storage of information and all of that. But it goes beyond. It goes beyond. Stores critical information and helps access data quickly and secure. Therefore, actually, which is actually of database. First, reduce redundancy. Database actually reduce redundancy. Then the approach, the manner of approach database is actually quite cumbersome.
Sorry, Bolan, can you please move a bit? Because your voice is kind of breaking.
Okay. Like I said, Lauren. Like I said, actually that it reduces redundancy in the sense that there is no bottleneck or cumbersome nature as to the results or outcome that database. Then we move down to the integrity. Integrity and accuracy. It speeds up accuracy. The database also has the ability to manage right now, and it is the talk of the town. Database has come to stay in the digital space, so it has the ability to adapt to change. It also has was 100%. And as regards to the security, there is an improved data access using host and query language. The security is of quality actually. And we I'm move next to the database architecture. When you hear the word database architecture, it is a representation of database system design. It helps to design, develop, implement, and maintain the database management system. Then, from our table here, we see so I'm going to start from 1 to 1. Actually, 1 to 1 actually states that in this context here, 1 to 1 database architecture actually deals with database always the same one. You can see from the employer ID 55, just the same machine, just a single input. Now move to many. Actually, one to many state that the database architecture, it is a database architecture where the presentation layer the presentation layer runs on mobile network. Many to many, actually, that is all about and clients use the most in what in actually in getting to what database. So I plan to introduce my institutional database. What to use Sarah?
Good afternoon, everyone. My name is Adeni Sarah, a student from the University of Lagos, Department of Computer Science. I'll be talking about the relational database. The relational database was invented by E.F. Wood. He was a British mathematician. He worked at IBM. He defined the relational database to be organization of information into tables of record, thereby linking fields in one table to fields in another table with matching data. And it separates data from paths to retrieve data from database to allow the database to be less dependent on the hardware and the operating system. Like the table we have on the screen, we have this table for the students and the registration. On the table for the student, we have the student ID, the last name, the first name, the birth date. And for the registration, we have the registration number, the student ID, the class code, and grade. And it is connecting both the student and the registration together. So we move to our next slide that talks about the data model. So we have two data models. So and under the data model, we have the kinds of data model. We have the entity and the attribute. We have the primary key and the normalization. For the entity and attribute, we know that for a data model must have an entity, and those entity must consist of the attribute that describes the entity. Every table in a record must have a primary key. And in normalization, the normalization is for entities. We move to the next data model that says data. Move to the next data model. And underneath, we have two kinds of data model. We have the relationship and foreign keys, and we have the complex relationship. Every table that has attributes as the model has a foreign key and the complex relationship too. We move to the next one, which says retrieving information. We have three forms of retrieving information: the structured query language, the interactive voice response, the natural language query language. The structured query language is the most common form of retrieving information. It makes use of queries, while the interactive voice response it makes use. We have the natural language interface. Move to the next slide that tells us how we manage information, managing the database. We have the performance, tuning, and scalability. We have the integrity, security, and recovery, and we have the documentation. For the performance, tuning, and scalability, every database must have a tuning to ensure for the integrity. The database should have integrity. The database administrator should have integrity to ensure optimal performance. And for the documentation, the database makes use of database schema to document information gotten from database. So the next slide is the data warehouse, and it's going to be taken by my colleague, Ngori Isaac.
Yeah, thank you, Sarah. Okay, yeah, good day, guys. This is Mori Isaac, Actual Science. So I'm taking the data warehouse. Okay, basically, the data warehouse is the central data repository that's containing information drawn from multiple sources that can be used for analysis and intelligence gathering and also strategic planning. So the process to build a data warehouse from operational databases are adding some external sources and manageable for most organizations and is extremely useful. Consider also how much semi-structured and unstructured information that flows around, like let's say social media now, like Twitter, YouTube, Facebook, Instagram, of which could give the company a competitive advantage if analyzed quickly. That's like in terms of making advertisement and stuff. So like when you collect all the data from all these sources, like when we get to talk about the examples for the external um that's the external sources of data warehouse, you get to know why all these stuffs are important. So consider the data like for competitive advantage if analyzed quickly. So the amount of data available is also exploding because of the authenticity of the data that is needed for an organization. So I'll be taking the examples now from the slide. That's as you can see from the picture, the PDF now, you see it there. So we have two types. Actually, we have the internal and the external data sources. The internal is basically like within the organization. So looking at the customer, looking at the staff, looking at the manager and all that. So that's just it, basically the information that is collected within the organization. And we can see from the first one, we can see the operational data there. The operational data is a type of database that's often used as an interim logical area for a data warehouse. So it's just like from the daily activity of the organization, the operation of the organization, basically. So the data is being collected, that's what has been done for the day, the sign in and the sign out, and just basically the activities of the organization for that day is being collated. As you can see, that's the operational data. And before all these examples can be transferred to the data warehouse, they need to be like you need to extract them, you need to transform them, and you need to load them before you now proceed to transfer them to the data warehouse. So the second example there, under the internal data sources, you can see the consumer data. This one is just basically your customers. So it could be their Gmail, their address, their phone number, and all that. So you need to collect all this data. Then when you finish extracting the data, you transform the data, then you load the data into the data warehouse, basically. So you have the inventory there, which is the third one. You have the manufacturing data. Manufacturing data is like the whole of the data of the day to day. That's like if it's a manufacturing firm now, say like a mining firm or something. So basically, that's just what it is. And also from there, from the slide, you can also see the achieved history data. Let's say like if the former employees, and you want to check, you want to look back to the performance of the employee, you go back to that data, or you want to check like the past um, day-to-day running of the business, you go back. That's just what the advanced, that's the achieved history data means. And also you can see the metadata from the slide. You can see there is drawn from documents and multimedia and other sources. And the next one, you can see the website traffic data. That's website. That's what I was explaining at first, that I mentioned Instagram, likes of Instagram, Twitter, and the likes. So it's just basically collecting all these data from different sources in an organization, extracting them, transforming them, and loading them into the data warehouse. So you can still go back and visit them, review them. That's what you can see from the second slide. That's from the right-hand side of the slide, basically. So also we have examples of external data sources. We have sensors data. We have GPS mapping, coordinates, and we also have the competitor information. This one is just like a broader picture, like a broader part of the data before transferring it to the data warehouse, basically. So for the competitor information, you want to see what the people outside the organization, that's like threats. You want to check their day-to-day activities, then collecting their information, reviewing it, comparing it with your own before transferring it to the data warehouse. And also from the right-hand side, you can see it after the data has been sent to the data warehouse, after it has been extracted, after it has been transformed, and after it has been loaded into the data warehouse. So you now access it. Then if there's need to mine it, you mine the data. That's like you review the data. If there's any query, you check for any query. And if there's any special reports and research. So that's just it basically. And from here, I'd like to introduce my other team member, Olajide Olufemi. Thank you.
Okay, I'll be taking the last part of this topic. My name is Olajide Olufemi. I'll be taking a student of Department of Actual Science, University of Lagos, 300 level. Taking the last speaker of the talk for the data as a topic. So we have a distributed data base, and I also be talking about distributed database architecture also, and the human elements that interact with information management. So now, distributed database, it involves parts or all portions of database being installed in different server all around the world. It gives information, it gives access to information, it's easy access to information for people all around the world. And as for there's a connection between distributed database architecture and distributed database. Distributed database architecture is like a design used to create a distributed database. For example, let's use a blockchain. A blockchain is like a design used to for transactions of the cryptocurrencies like Bitcoin, Dogecoin, Tron, and so on and so forth. So now I'll move down to human elements, how human elements interact with information management. This is talking about information management as a whole, but these are the kind of the factors that interact with information management to make it a success, to make the information useful. One is that is the part of the human elements are ownership issues, shadow system, and then MSM, which is known as master data MDM, master data management. So ownership issues has to do with the ownership when it comes to information, how information are being used, how data are being used. But the shadow system talks about how people want to get their job effectively done and fast. And then the only solution to get that as done as soon as possible is creation of shadow system. They are like database created to assist to make work done faster. Then why the master data management is what is a broader strategy to address inconsistency in the way people use their data, like why using data issues that come up while using this data, like a kind of a break using this data. These are what the master data management addresses. Now we look at the second part of the human element that talks about the data stewards, database without boundaries and stakeholders. we all know, okay, data, um, the second speaker spoke about database, and we all know how data is like a raw fact. Data steward, how it talks about how it interacts with information management. Data steward, they are like what? They are like watchdog or bridge builders to remind everyone how data are being used, how data is what is being defined. They are like people that help through and explain how data are being defined. So like, okay, like we have large numbers of customer suppliers that want to use data, we want to use information. So like these people, these data stewards are the one that they are the ones that put them through and tell them how data is being defined. And this is database without boundaries. So when you explain what database, how database is so enormous to a particular extent. We talk about how they are being put in on different servers for people to be able to access information. They will have stakeholders of this information management. And I'll explain a particular scenario that happened in UK police case that explains how information and management works. It talks about the video surveillance, the video surveillance of how they check in cars, where we move down to automatic plate number recognition. They have CCTV camera that checks those things, and you have to have the database. They have details of all each and every car, the details of their plate number. They have queries and data mining. They have privacy. So this explains how information management works. And then conclusion on this particular topic, you can actually say enterprise information management is not all about technology. All we are talking about is not all about technology. There are challenges that could actually come in place that disrupt human elements on this information management. Also, we're talking about leadership, corporations, negotiation, a well-designed database, awards are all needed to balance the stakeholder requirements. Stakeholders that need requirements for a particular business. These are the things that actually that can be put together to provide information for them. And that will be all on data and data warehouse. And looking at table of content, we've treated information resources, database, relational database, data warehouse, distributed database, and last information management. Thank you very much for listening.